Rain-fed agriculture has been the dominant source of food and livelihoods for the majority of the people. From time immemorial, the rural poor communities in Uganda and parts of the sub-Saharan African region knew when to plant and when to harvest their crops, thanks to the gift of nature that presented definite dry and wet seasons that supported the farmers' systems year in and year out. But not anymore. Today, the farming communities are at the crossroads. They can hardly predict when the rains are likely to come, what to do when they come late, how to manage the long dry spells that burn off their crops and starve their livestock, or the enormous rainfall which sweep away their crops, livestock, and other household properties, forcing the farmers to live in a state of despair. And so, over the years, the farmers and development practitioners have developed innovative practices and technologies to cope with the radical changes in the climate. PELUM Uganda, a network of different organizations promoting sustainable farming systems amongst the smallholder farmers for enhancing agricultural productivity, is spearheading the drive to document such technologies to popularize and scale them out to benefit a much wider audience.
We started the campaign in 2009, where we conducted a study trying to understand how smallholder farmers understand climate change and also the existing local initiatives. We are looking at those simple but efficient and effective technologies that are out there that have been tested by the farmers themselves for at least 5 years. But we realize that most of these are localized. You would find that farmers in Nakasongola are not knowing what is happening in Mubende, for instance. And that is why we try to identify these practices and trying to disseminate it to our members.
This video documentary explores some of the farming tools, practices, and technologies that the farmers in different parts of the country have adopted and proven cheap, efficient, and effective in mitigating the effects of climate change. This water is harvested from rooftops. According to this farmer, his sheltered underground tank is very profitable. It is cheap, easy to construct, and user-friendly because the water source is within reach for all their family members. Above all, the water is clean and available all the time. This is very crucial for the farmer to maximize on-farm productivity and helps them to earn more money through selling the farm produce when everybody else is out of season. Farmers in the low-lying areas use the surface water runoff harvesting techniques to collect water in reservoirs for their household activities, particularly during dry seasons. Mrs. Mayanja Immaculate, for example, with just 60,000 shillings, was able to construct a tank of 12 by 8 feet by 3.5 feet and lined it with a strong polythene material called tundubali to hold 250,000 liters of water. The water in the reservoir will then be available to irrigate their crops and to water their animals. This water cabbage purifies the water to make it safe for animals and other domestic uses. On hilly terrains, some farmers have adopted soil and water conservation technologies, such as fanyachin and fanyaju. The technology traps the moving water and channels it into the contours where it settles and percolates slowly into the soil. It will then be available for the crop for a much longer time after the rainy season. For maximum results, the farmers have to regularly maintain the trenches by removing the nutrient-rich soils piling up in the trenches and return it to the field after the surface runoff has dried up to support the crops even during the hostile conditions. Alongside the trenches, the farmers have also adopted the mulching technology. The mulch not only controls water loss, especially through evaporation, but also improves soil fertility. Mulching also minimizes the impact of soil erosion on the farm. It reduces the impact of raindrops disintegrating the soil particles, as well as reducing the runoff velocity. This allows the water more time to infiltrate into the soil to be available for the crops, even during the hostile climatic conditions. Some farmers, instead of using the commonly practiced dry mulch, they plant cover crops and the shrubs. It is the rooting system and the crawling nature of the plants which produce the magic results.
Omwaka 2020 olusuku lwali lufuire ayi mpera no twafuna amagezi okuba nga tuli kusimba muno mu lusuku muno ebintu bino bimukuna ate ebintu ebyo birina omugaso kuba bukola ki ekijimusa mu itaka muno n'ekindi bibwika olusuku n'eisubi lyaloba kuba ki lingi.
The Nkola family has every reason to thank Africa 2000 Network, another organization promoting conservation agriculture in Budaka and Tororo districts. The most outstanding success they recall is when an elongated drought spell struck 2 years ago. Even though their soils have a poor water retention capacity, they were not as affected as their neighbors who had declined to embrace the technologies. The principle involves minimal disturbance of the soils and keeping it covered. The technology also promotes mixed cropping and crop rotation, all of which enables the farmers to improve their soil fertility.
Conservation agriculture is applicable in almost all regions in Uganda because each region is having a unique problem. When you go to the highlands, you have issues of soil erosion, landslides, and many other problems. When you go to the lowlands, there's limited rainfall, poor soil fertility, and so on. So conservation agriculture is out there to address some of those constraints. Short of it, we will not be able to produce and feed the population, and short of it, we cannot fight poverty.
The composting and kitchen gardening technology has helped the farmers, especially those with limited land, to produce food both for the home and the market. Kitchen gardens, sometimes referred to as backyard gardens, are constructed within or nearby the homestead for convenient management.
Kitchen garden eyo gyolaba bw'oba ogikoze obulungi nga bwe tugikola bulungi ne bwe waako omusana gwenkana ki ennimiro eyo tesobola okukala. Ekirala eno enkuba bwe zijja ennimiro zonna zigenda amazzi ne gazitwala naye amazzi tegasobola kusitula gino ensawo ne gagitwala wano nga oguba harvestinga katungulu wano oba olya nakati.
In here, the farmers rear animals alongside crop husbandry. The integration approach completes the farming cycle with a lot of ease. The animals produce urine and dung to fertilize the soils to support crop growth. Part of the crop harvest, such as yam leaves, napier grass, and caliandra, in turn, besides other values, produce animal feed to increase the animal productivity so that they can produce enough milk or meat for the farmer. The well-fed animals then produce urine and dung to start the cycle all over again. Other farmers use the animal dung and urine to produce biogas for cooking and lighting in their houses, and the bioslurry to supply ready-to-use nutrients for the plants. The plants will grow and yield profusely even under the armpits of the most hostile drought condition.
Mu 2008 omusana gwagenda ne gwaka kumpi mwaka mulamba naye laffe embeera yaffe teyakyuka olw'ensonga ebisabiri biba by'amazzi ngenda mbiyiwa mu mmere yange oba mu bitooke nga ngenda njiwamu oba mu mwanyi nga njiwamu oba mu nva zange nga njiwamu mba nziriisa bulungi.
This technology is handy. Dripping water, usually from a customized source, is directed at regulated intervals to the plant's rooting region. By so doing, the plant receives and efficiently utilizes the little water, and even under acute drought conditions, they can survive to offer maximum productivity to the farmer all the year round. According to the farmers, this technology is capable of improving food security and consequently increases farmers' incomes. Other farmers have come up with innovative ways to cut down the costs of the drip irrigation technology. At St. Jude Family Projects, for example, instead of the plastic tank, the farmer is using buckets. The impact realized is still the same, but at a much cheaper cost.
Kati bucketi erimu bweba bagisedde nnyo bayagu mu kitundu. Ogenda okugula obupiira nabwo tebuba bwa sente nnyingi. Akapiira kamu kayinza okuba mu siringi 7,000. Ojja buzi ku makya n'oteeka amazzi mu bucketi n'ogenda oddamu nkeera.
St. Jude has the bottle irrigation option too. For the very poor farmers who still cannot afford the bucket irrigation system, the bottle irrigation system is almost cost-free because used bottles such as these picked from the waste pits can accomplish the wonder job. The skill involves piercing a tiny hole on top of the bottle to act as a dripping valve, and then beneath it to release the air. Though labor-intensive, especially when used on a large scale, the innovation is cheap, irrigates the crop effectively, and the yields are promising. Deforestation is one of the major land use practices blamed for intensifying climate change. Because of the many benefits associated with forestry with no foreseeable alternative in the near future, agricultural specialists and environmental protection proponents are promoting agroforestry, a technology that can accommodate both trees and crops on the same piece of land. These fruiting trees are 2 years old and the intercrop bananas are almost as old. The 2-acre piece of land belongs to Mr. and Mrs. Kambere, the early adopters of the intercropping technology. The garden on a sloping terrain that could hardly produce food for the family for a long time can now produce even more surplus for the market. On top of the increased cash flow into the family, Mrs. Kambere says that even when the fruits or the bananas are off-season, the trees still protect their land from the vagaries of nature, for example, wind erosion. They have also stabilized the soils from landslides and even rejuvenated the soil fertility because when the leaves from the trees decompose, they form humus for the soil. All the benefits put together, agroforestry has no doubt joined the list of practices many farmers are taking up to mitigate the effects of climate change. Growing more than one crop on the same piece of land is yet another method that farmers are increasingly taking up. In many parts of the country, the farmers are intercropping perennial with seasonal crops to tap into the enormous benefits that come with the technology. A typical example is this farm interplanted with groundnuts and bananas to primarily enrich the soil with nitrogen. Weeding the groundnuts will also benefit the bananas, and the farmer will not have to wait for long before harvesting the groundnuts as the matoke matures up too. Some farmers are using this technology to beat off the challenge of pests and diseases. They intercrop their gardens with pest-repellent crops with a nauseating smell that keeps away many pests whose influx increases with changing climate. As the weather patterns continue changing, the farmers' options for the crops have changed to suit their circumstances.
Ettaka lyeno twaligezesaako nga twakajja kuno nga emmere eno terisobola naye okuva twatandika okussa mu bikutiya muno waliwo enjawulo osobola okujjako endebe ate terina nnyo obugongolo nabuuka kati ate tukuŋŋaanya ffe amazzi gonna agoozeddwa mu bintu agoozeddwa mu ngoye ne tuteekamu evvu n'ekidagala kyaffe ekyo kyolaba ekimyula ne tufukirira kuno mu biseera eby'omusana.
This is another variety of yams, locally known as bukupa. Many communities in drought-prone areas are growing them because of their resilience to the hostile climatic conditions, providing them with nutritious vegetables, food, as well as feed for their livestock. Agronomic studies attach its adaptation capability to its broad leaves and overall plant structure that holds on to the water stalks for use in the strenuous conditions and its capability to use large volumes of carbon gases from the environment.
Ejjuuni lino liyinza okumala emyezi ng'ebiri nga tonnakuliwaata ate nga likyaliddamu era n'olifumba ng'emmere yalyo ekyali nnungi ddala.
RUSED is promoting the post-harvest handling technology amongst the communities to process foodstuffs to increase their shelf life and their market value. To ensure sustainable supply of the required raw materials, RUSED is linking up with outgrowers, a phenomenon that is motivating many people to plant fruit trees in order to tap into the ready market for the fruits. Ecological Christian Organization, a local non-governmental organization, is implementing the climate-proof disaster risk reduction project. The project is intended to build communities in the most fragile ecosystems in Karamoja to enhance sustainable management of climate change impacts and supporting the target community in understanding and analyzing the possible scenarios of climate change and disaster risk reduction measures in respect to their livelihoods. The communities within the project area have started implementing the different climate change adaptation mechanisms and also becoming very cautious of the different natural resource management schemes to reduce on the impacts that come with climate change.
So when you go in one of our target communities in Kapilipiliti, Nabiratu, and Rurachat sub-counties, we have worked with these communities to set up small-scale irrigation schemes. We are tapping the cow dung, which produces methane that contributes to climate change, into biogas, and a number of households are lighting, and they're using the biogas for cooking, and the residues from the biogas are used as fertilizers. There is a very strong tree species which is called the ecorate. This is a tree that has been deep-rooted so much in Karamoja area, yet we can call it a climate-proof tree that has got a lot of medicinal values. Is used as fodder. All the leaves can be used as vegetables. And this has been one of the key issues that the committee has identified. So they have demarcated some areas where that tree is going to be planted to bring it back to its natural setting.
The most important thing right now is more stakeholders coming together to share knowledge and experiences on climate change. We need to see how we integrate the existing indigenous knowledge with the new technologies that have been tested, that they increase the adaptive capacity of the farmers, but also help in mitigation to climate change. And I think this is where the government and all the other stakeholders need to put emphasis.